A body of mass 5 kg is moving with a velocity of 2 meters per second. Calculate its linear momentum. There is a body having mass of 5 kg. It is moving with a velocity of 2 meters per second. Linear momentum is the product of mass of the body and velocity of the body. Mass of the body is 5 kilograms and velocity is 2 meters per second. Let us substitute these values. P is equal to 5 kg multiplied by 2 meters per second. So the linear momentum will be 10 kg meters per second. The linear momentum of a ball of mass 50 grams is 0.5 kg meters per second. Find its velocity. So there is a ball whose mass is 50 grams, which is equal to 0.05 kilograms. Now the momentum is provided. It is 0.5 kg meter per second. To find the velocity, we will use the formula for momentum. P is equal to mass multiplied by velocity. Let us rearrange this in terms of velocity. So V will be equal to momentum divided by mass. Velocity is equal to 0.5, that is the momentum, divided by mass, which is 0.05. So the answer will be 10 meters per second. Velocity is 10 meters per second. This is our final answer. A force of 15 Newton acts on a body of mass 2 kilograms. Calculate the acceleration produced. A force of 15 newtons is acting on this body. This body is having mass of 2 kilograms. So what is the acceleration produced because of this force? Now force is the product of mass and acceleration. Let us rearrange the terms in this formula. A will be equal to force divided by mass. Force is already given in the statement of the problem. It is 15 newtons and mass of the body is 2 kilograms. So let us substitute these values. So A will be equal to 15 divided by 2. That will be equal to 7.5 meters per second square. So the acceleration produced because of the force is 7.5 meters per second square. A force of 10 Newton acts on a body of mass 5 kilograms. Find the acceleration produced. A force of 10 Newton is acting on this body, due to which some acceleration will be there. We need to calculate that value of acceleration. Now, Force is the product of mass and acceleration. If we rearrange the terms in this formula, we can write it as A equal to F divided by M. The value of force is already there in the statement of the problem. It is 10 newtons. And mass is also there. It is 5 kgs. Let us substitute these values. So A will be equal to 10 divided by 5. So acceleration produced will be 2 meters per second square. Calculate the magnitude of force which, when applied on a body of mass 0.5 kilograms, produces an acceleration of 5 meters per second square. Now, here is a body having mass of just 0.5 kg. Acceleration of this body is 5 meters per second square. We need to calculate the magnitude of force. Now, force is the product of mass and acceleration of the body. Mass of the body is 0.5 kilograms and acceleration is 5 meters per second square. So, F will be equal to 2.5 newtons. A force of 10 Newton acts on a body of mass 2 kilograms for 3 seconds, initially at rest. Calculate velocity acquired by the body and change in momentum of the body. So here is a body on which the force is acting. The force is 10 newtons. Mass of this body is 2 kilograms. Time is 3 seconds. To find the value of velocity, first we need to calculate the acceleration. Force is the product of mass of the body and acceleration of the body. Therefore, acceleration is equal to force divided by mass. Force is 10 Newton divided by mass of 2 kilograms. So the acceleration will be equal to 5 meters per second square. Now velocity can be obtained using this equation. V is equal to U plus AT. The body was initially at rest. Therefore, U will be equal to 0. Therefore, this equation can be written as V equal to AT. Now, let us substitute the values. Acceleration is 5 meters per second square and time is 3 seconds. So velocity will be 15 meters per second. So this is our first answer. Velocity is equal to 15 meters per second. Now let us find the momentum. The change in momentum specifically. So change in momentum delta P is equal to final momentum minus initial momentum. Momentum is the product of mass and velocity. So I can write it like this: mv minus mu. The mass is not changing. The initial velocity is 0. u is 0. So delta P will be equal to mv. Now let us substitute the values. Mass is 2 kilograms and velocity is 15 meters per second. Therefore, change in momentum will be 30 kg meters per second. So this is the change in momentum. Delta P is equal to 30 kg meters per second. A force acts for 10 seconds on a stationary body of mass 100 kilograms, after which the force ceases to act. The body moves through a distance of 100 meters in the next 5 seconds. Calculate velocity acquired by the body, acceleration produced by the force, and magnitude of the force. Now, there is a body of mass 100 kilograms. A force is acting on this body for 10 seconds. Because of this force, body moves through a distance of 100 meters. So it is moving 100 meters. In the next 5 seconds. Okay. So this time is 5 seconds. Okay. So force is acting for 10 seconds and the body moved 100 meters in the next 5 seconds. Okay. First we need to calculate the velocity acquired by the body due to this force. So let us find out. Since the force has stopped acting, body is moving with constant velocity. We can calculate this velocity using the formula for uniform motion. So V is equal to, velocity is equal to the distance it has moved. Let us say distance is S divided by T. So what is the distance moved? Distance by time, 100 divided by the time in which that body moved from position A to position B. Okay. So the time was 5 seconds. Yes. So that would mean that the velocity will be 20 meters per second. Okay. So velocity is 20 meters per second. Now, let us calculate the acceleration produced by this force. Now, the body was stationary initially. We can use the equation of motion to find the acceleration A. Now, V is equal to u plus at. Here V is the final velocity, u is the initial velocity, a is the acceleration and t is the time. U is equal to 0 as the body was stationary. Okay, this is the initial velocity. So u is equal to 0 meters per second, v is 20 meters per second and t is 10 seconds, time during which the force acted. Okay, it is clearly mentioned acceleration produced by the force, and the force acted on this body for 10 seconds. So we will consider this 10 seconds as t here. Okay, because force acted for 10 seconds. So let us rearrange this equation to solve for acceleration. So AT will be equal to V and A will be equal to V divided by T. Okay. So now let us substitute the values. A is velocity is 20 meters per second. Time is 10 seconds. Okay. So force acted on this body for 10 seconds, which caused the acceleration. So acceleration will be equal to 2 meters per second square. So this is our answer. A is equal to 2 meters per second square. Now we need to find the magnitude of the force. Now the magnitude of force can be calculated using the Newton's second law. Force is the product of mass and acceleration. Here the mass is 100 kilograms and acceleration we just calculated, it is 2 meters per second square. So on substituting the values and multiplying, we'll get F equal to 200 newtons. So F is equal to 200 newtons. The figure shows the velocity time graph of a particle of mass 100 grams moving in a straight line. Calculate the force acting on the particle. So there is a particle of mass 100 grams. It is moving in a straight line. Now in this velocity time graph, velocity is on the y-axis and time is on the x-axis. It's a straight line indicating uniform acceleration. The slope of the velocity time graph gives the value of acceleration. From this graph, the velocity increases from, let us see carefully, the velocity is increasing from 0 meters per second to 20 meters per second in 0, 1, 2, 3, 4, 5 seconds. So in 5 seconds, velocity is increasing from 0 meters per second to 5 meters per second. So delta V is final velocity minus initial velocity. That will be equal to 20 meters per second minus 0 meters per second. So delta V, change in velocity, will be 20 meters per second. The time is 5 seconds. Delta T is 5 seconds. You can see the time increases from 0 to 5 seconds. The slope A, acceleration, is delta V divided by delta T. So acceleration is equal to delta V divided by delta T. So this will be equal to, delta V is 20 minus 0. I have already calculated that. Delta T is 5 seconds. So acceleration will be equal to 4 meters per second square. Now we can easily calculate the force. We have the value of acceleration here. Now force is the product of mass and acceleration of the body. Mass of the particle is 100 grams and acceleration is 4 meter per second square. Let us substitute these values. F is equal to mass 100 grams. We need to convert that to kilograms. So 100 gram will be equal to 100 divided by 1000. That will be equal to 0.1 kilogram. F is equal to 0.1 kg multiplied by 4 meters per second square. So this will be equal to 0.4 newtons. So the final answer is 0.4 newton of force. A force causes an acceleration of 10 meters per second square in a body of mass 500 grams. What acceleration will be caused by the same force in a body of mass 5 kilograms? So here is a body having mass of just 500 grams. So that will be equal to 500 divided by 1000 gives us 0.5 kilograms. Now there is a force acting on this body which causes an acceleration of 10 meters per second square. Same force is acting on another body which is having mass of 5 kg. What is the acceleration caused by this force? That's what we need to find. First, let us calculate the force. Force is the product of mass and acceleration. Mass of this body is 0.5 kg and acceleration is 10 meters per second square. So the force will be equal to 5 newtons. Now we have calculated the force. It is 5 newton. Force is the product of mass and acceleration. Here we need to find the value of acceleration. Therefore, let us rewrite this in terms of acceleration. Acceleration will be equal to force divided by mass. Acceleration is equal to force, which is 5 newtons, divided by mass, which is 5 kilograms. So the answer will be 1 meter per second square. The acceleration caused by force of 5 newton on a body of mass 5 kilogram is 1 meter per second square. A cricket ball of mass 150 grams moving at a speed of 25 meters per second is brought to rest by a player in 0.03 seconds. Find the average force applied by the player. Mass of the ball is 150 grams. If we divide it by 1000, we will get the answer in kilograms. Mass is 0.15 kilograms. Speed is 25 meters per second. This is the initial speed. It is brought to rest by player in 0.03 seconds. We need to find the average force applied by the player. Let us first calculate the initial momentum. Initial momentum Pi is equal to m multiplied by u, mass multiplied by velocity. Now mass is 0.15 kilograms, u is 25 meters per second. 25 multiplied by 0.15 will give you 3.75 kg meters per second. Now let us calculate the final momentum. Final momentum will be 0 because the final velocity V will be 0. Okay, so final momentum is M multiplied by V is equal to 0.15 multiplied by 0, which will be 0 kg meters per second. So the change in momentum will be delta P equal to P final minus P initial. Final momentum minus initial momentum. Final momentum is 0. Initial momentum was 3.75. So the change in momentum will be minus 3.75 kg meters per second. Now the average force is change in momentum by time. So let us find the force now. Force will be equal to delta P by time. So what is the momentum here? Minus 3.75 divided by the time. So the player stops the ball in 0.03 seconds. So if you do this calculation, you will get this answer minus 125 newtons. So the average force applied by the player to stop this ball will be minus 125 newtons. The negative sign indicates the force. It indicates that the force is applied in the opposite direction to the ball's motion. Again, I am repeating, this negative sign indicates that the force is applied in opposite direction to the motion of the ball. A force acts for 0.1 second on a body of mass 2 kilograms initially at rest. The force is then withdrawn and the body moves with a velocity of 2 meters per second. Find the magnitude of force. So in this problem, mass of the body is given. Mass of the body is 2 kilograms. Initially, the body is at rest. So initial velocity u is equal to 0. Final velocity acquired by the body is 2 meters per second. Find the magnitude of force. Time duration has also been provided. T is 0.1 second. We need to find the force which is applied on this body. Now let us first calculate the change in momentum. Change in momentum is final momentum minus initial momentum. Final momentum is the product of mass and velocity minus initial momentum, which is the product of mass and initial velocity. Initial velocity was 0. So this term will be 0. So delta P will be equal to mass, which is 2 kilograms, multiplied by the velocity, which is 2 meters per second. So delta P will be 4 kg meters per second. Rate of change of momentum is force. Force is equal to delta P by T. Okay. So now let us substitute the values. 4 kg meters per second divided by time, which is 0.1 second. So this will be 40 newtons. The magnitude of force acting on this body is 40 newtons. A body of mass 500 grams initially at rest is acted upon by a force which causes it to move a distance of 4 meters in 2 seconds. Calculate the force applied. Here is a body having mass of 500 grams. Let us convert it into kilograms. So m will be 0.5 kilograms. Just you need to divide it by 1000 to get the mass in kilograms. Now, because of some force, it moved a distance of 4 meters. It moved a distance of 4 meters in 2 seconds. Calculate the force applied. We need to find the force which caused this body to move a distance of 4 meters. Now, let us use the equation of motion. S is equal to ut plus half at square. Initial velocity was 0. Initially the body was at rest, so u would be equal to 0. S is the distance, it is 4 meters, time is 2 seconds. Let us substitute the values. So 4 equal to 0 multiplied by 2 seconds plus half multiplied by a, which is what we need to find right now, multiplied by t square, that is 2 square. So 4 is equal to 0 plus half a multiplied by 4. 2 2s are 4. So 4 is equal to 2a. Therefore, a will be equal to 2 meters per second square. Now, force is the product of mass and acceleration. F is equal to ma. Mass is 0.5 kilograms multiplied by acceleration, which is 2 meters per second square. So, force will be 1 Newton. 1 Newton of force was responsible for moving this body by a distance of 4 meters in 2 seconds. A car of mass 480 kilograms moving at a speed of 54 kilometers per hour is stopped by applying brakes in 10 seconds. Calculate the force applied by the brakes. Mass of the car is 480 kilograms. It was moving at a speed of 54 kilometers per hour. So initial velocity u is 54 kilometers per hour. It came to a stop in 10 seconds. The final velocity is 0. Calculate the force applied by the brakes. We will use the equation of motion. V is equal to u plus a t. First of all, we need to convert initial velocity in meters per second. So let us do that. U is equal to 54 kilometers per hour. 1 kilometer is 1000 meters and 1 hour is 3600 seconds. So that will be 54 multiplied by 1000 divided by 3600. So if you do this calculation, you will get U equal to 15 meters per second. So we'll be using this value of initial velocity. Now let us substitute these values. Final velocity is 0. Initial velocity 15 meters per second plus A, that's what we are supposed to calculate right now, multiplied by time, which is 10 seconds. So this will give me 10A equal to minus 15. So A will be equal to minus 1.5 meters per second square. Actually, this is the deceleration. It is not the acceleration, it is the retardation, or we can call it deceleration. Now let us substitute these values into the equation. Force equal to mass multiplied by acceleration. F is equal to m multiplied by A. We have the value of mass, yes, 480 kilograms. We just calculated the value of A, which is minus 1.5 meters per second square. Negative sign shows that it is slowing down. So m is 480 multiplied by minus 1.5. So F will be equal to, if you do the calculation, you will find that the force is minus 720 newtons. A bullet of mass 50 grams moving with an initial velocity of 100 meters per second strikes a wooden block and comes to a rest after penetrating a distance of 2 centimeters in it. Calculate initial momentum of the bullet, final momentum of the bullet, retardation caused by the wooden block, and resistive force exerted by the wooden block. Mass of the bullet is 50 grams. That will be equal to 0.05 kilograms. Initial velocity U is 100 meters per second. It comes to a stop after penetrating through a distance of 2 centimeters. Final velocity is 0 meters per second. Now let us calculate the initial momentum. Momentum is the product of mass and velocity. Pi is equal to mass multiplied by initial velocity. So what is mass? Mass is 0.05. What is the initial velocity? It was 100 meters per second. So this gives us the initial momentum. Initial momentum will be 5 kg meters per second. Now let us calculate the final momentum. Final momentum is mass multiplied by final velocity. Mass is 0.05 kg and final velocity is 0. So that would mean that the final momentum would be 0 kg meters per second. Now let us calculate the retardation caused by the wooden block. The value of time has not been provided. We have been provided with the value of distance through which the bullet is penetrating into the wooden block. The distance is 2 centimeters. So S is 2 centimeters. That would be 0.02 meters. Now let us use an equation of motion here. We have the initial velocity, we have the final velocity. We need to find the value of A, and we also have the value of distance here. Okay, so the appropriate equation in this case would be V square equal to U square plus 2AS. Now let us substitute the values. V square is 0 because the final velocity is 0. U square is 100 square plus 2 multiplied by A multiplied by 0.02. So 100 square will be 10,000. 10,000 goes on one side, so it becomes minus, equal to 0.04. 2 multiplied by 0.02 will be 0.04 A. Therefore, A will be equal to minus 10,000 divided by 0.04. So retardation would be, two zeros will come here, so minus 250000. Yes, this would be the retardation. So we can write the retardation like this also. A will be equal to, you can also write like this, minus 2.5 multiplied by 10 raised to 5 meters per second square. Negative sign shows that the direction is opposite to the direction of the bullet. The magnitude of retardation, you can write it as 2.5 multiplied by 10 raised to 5 meters per second square. Now let us calculate the resistive force exerted by the block on the bullet. F is equal to mass multiplied by acceleration. So mass is 0.05 kgs, acceleration 2.5 multiplied by 10 raised to 5 meters per second square. Actually, this is retardation because it is acting in opposite direction to the direction of the bullet. So the final answer will be 12.5 multiplied by 10 raised to 3 newtons. Or you can also write it as 12,500 newtons. This is the final answer.